I am very happy to introduce Chloe Condon, who is a prolific writer on Medium. She has a very famous post on women in tech, but also writes a lot about Docker. You can also find her on Twitter at Chloe Condon. And she is going to introduce Docker, the very basics of Docker. If you are here to learn on the core concepts of Docker, she is the one to tell you. Welcome, Chloe.
Thank you. Oh, thank you. Hello, everyone. That is my backpack in the photo there. That is my hair. So thank you for coming. My name is Chloe Condon, and I'm a developer evangelist at CodeFresh. It's pretty surreal being on the DockerCon stage because about 7 months ago, I was attending my very, very first DockerCon in Austin. So I was a bit of a Docker newbie when I was there. And since I had just begun working at CodeFresh, that's our little mascot with a little piece of luggage there, I had to ramp up on Docker pretty quickly. So I really viewed my first DockerCon as an opportunity to absorb as much as I could about the Docker community, about Docker in general, and I also tried to meet with as many Docker captains as I could. Spoiler alert, if you haven't read my blog on that, I ended up meeting with 16. It was very ambitious. So DockerCon is my favorite conference, and I'm not just saying that because I'm on stage here. The Docker community is so friendly, warm, welcoming, and I'm very, very happy to be a part of it. So thank you for having me, Docker. If you're at this talk because you're not really sure, let's see, I touched something, oh no. Okay, there we go. Okay, I'm not going to touch that anymore. All right. So if you're here because you want to learn some tips and tricks how to get started with Docker, you're definitely in the right place. Or if you are here to help teach other people how to learn how to do Docker, I hope some of my quirky metaphors, memory hooks, and tips can help you teach others. So that's me at my last DockerCon, and I'm whaley glad you're here. And I have to preface this by saying, I tell a lot of dad jokes, and I apologize in advance, but I also want you to have full permission to laugh. I used to be a musical theater actress, so I'm very used to audience reaction, so laugh at all my jokes. That is totally fine with me. Or not, whatever you want to do. So I attended Hackbright in 2017. It's an all-female software engineering fellowship in San Francisco. And Docker was not something that was taught in my curriculum. So you can imagine the look on my face when I had my phone screen with what would be my future manager, and he asked me, "How much do you know about Docker?" Nothing. It feels like you can prepare for as many different whiteboarding algorithms and whatnot to be prepared to interview, but there's always going to be a technology that you don't know. So I was given a take-home challenge to Dockerize my application that I had made at Hackbright. And being the engineer that I am, who's very professional and skilled, I did what all professional, skilled engineers do. And I Googled Docker. And I searched on Stack Overflow and tried to learn as much as I could about Docker in a very short amount of time before I went to my in-person interview. So up until this point, Docker was totally not part of my technical vocabulary. And once I Dockerized my app, I was finally able to build and deploy my application on CodeFresh. And we're a Docker native CI/CD, so I could build, test, and deploy. And I could also spin up a pre-staging environment, which was not bad for a junior engineer. So I gave myself a little pat on the back for that. So needless to say, I got the job, and now I'm here. So once I learned Docker, it completely changed the way that I thought about building software going forward. So now I'm a developer evangelist, and I have Docker to thank for that. So thank you, Docker. So let's start from the very beginning. A very good place to start. Oh, good. Okay, we have some Sound of Music fans. This is good. I'm getting a good vibe. All right. So I've tried to sprinkle some musical theater quotes in here to stay true to my roots. So if you catch them, extra bonus points for you. There's a test at the end. I'm just kidding. There's not a musical test at the end. So I'm going to cover a lot of things today. So I'm not going to spend too much time on the details here. But basically, I'm going to start with images and containers and talk about layers, DockerHub, official images, tagging and pushing, as well as Dockerfiles, volumes, persistent data, bind mounting, Docker Compose, all this fun stuff. If you don't know any of these words, it's totally okay. You will leave them hopefully having a sense of what they are. Hopefully, if I do my job right. So quick little demo. So what I'm going to do first is just kind of give you a walkthrough of the different things that I'm going to be talking about. And then I'm going to break them down individually. So if this goes kind of quickly for you, do not worry about that. So just give me a quick sec here to change screens. So I'm going to pull a Docker image, and then I'm going to run a container. All right. So excuse my tiptoes while I do this, guys. I'm reading it on the screen below me. All right. So the first thing I'm going to do is clear my terminal and make sure that I'm in the right file. So I have a very, very simple Flask application that I'm running, and I'll show you exactly what that is. So I'll go into my web folder here. And so it's very simple. I'll just show you here. So it's a Flask application. It has one route. It's just a hello world application that, well, no spoilers. I'll show you exactly what it is in just a second. But the first thing that I'm going to do, well, first I'm going to show you what my Docker file looks like. And I'm going to capitalize it. There we go. So that's my Docker file. And you can see it kind of looks like a recipe, kind of like a set of ingredients in a way. So I am going to build my Docker image. So I'm going to do docker build -t. And this is my Flask sample app. And I'm going to do latest. Oops, I'm going to go back here. All right. So clearly I've built this before, so that went very quickly. But you can see here it ran through all of those different steps that I showed you in my Docker file. So now I'm going to clear my screen, and I am going to do a Docker run. I can spell, I promise. -d-p, and then I'm going to run this on port 5000. There we go. And then I'm going to do Flask sample. All right. Cool. So it spit out this really fun number that kind of looks like my dad's Wi-Fi password that he refuses to make shorter. So I'm going to run so that's actually going to make a lot more sense in a moment. So I'm going to do, Docker container ls, so I can see my containers. Cool. So there's my container ID. My image name is Flask sample, and it was created a couple seconds ago, and it's running on port 5000. So let's see if that's actually true. All right. Woo, we did it. So now I'm going to stop this container. So I'm going to run a Docker stop. And don't worry, you don't have to write this full number sequence here. It's very hard for me to see. Is that 46E? Yep, okay. Cool, so now that container is stopped, if I do a Docker container ls, it is no longer running, and I will prove that. Cool. So, if I can spell clear right, that would be great. All right, so the next thing I'm going to do is I'm going to go down here, and I have a docker compose.yml file, so I'll show you what that looks like. All right, so pretty simple. So this is connecting the different containers that we have. So I'm going to run a docker compose up. Oops, I need to put a dash. Thank you. All right. Woo, okay, so now that is running on port 5000. Oh, I should have brought it down, but I swear that it works. So there we go. So we ran that 2 ways, and I'm going to break down the different pieces of the different things that we did, if I can find my cursor on the next screen. All right, demo time's over. So images and containers, what is the difference? So these are two really important keywords that you need to know when getting started with Docker. And oftentimes when I'm teaching new students about Docker, this is something that people get kind of hung up on. So I'm going to take a moment to break things down here. So let's break it down. An image is an application that you'd like to run, and a container is a running instance of an image. So in other words, you create a container based on an image, and therefore many containers can be run off of the same image. So a container is an instance of an image. Okay, that was a lot of words. You're probably feeling a little bit like this confused monkey. Oh no, He wasn't confused. Wait, you have to see the confused monkey, you guys. There we go. Or not. Oh, there he is. So let's break it down a little bit. So you can think of containers and images sort of like a class and an instance of a class. So here's just a really simple example in Python. So I've created whale, which takes in a name and location. And just for fun, I've created a speak function that says the name and location of said whale. So by creating an instance of the class whale, by creating whale1 at the end here, in this example, our image would be our class whale, and whale1 would be our container. So another way to think of it, and I've updated this to make it more relevant for the kids these days. Not really. This is if you'll see. Okay. So I like to give the comparison of images and containers as images of a DVD and containers being a DVD player. Hopefully people know what that is in the age of Netflix and Amazon Prime. So in this example, the DVD would be your image, and when you play the DVD on your DVD player, that would be your container. So in that, we're running the original DVD on it. So the container, in this case the DVD player, is always directly tied to the image. I should also make clear in this metaphor that you can only play one DVD at a time unless you've hacked up some Raspberry Pi thing to make things super crazy. So the comparison doesn't work in that sense, but that's kind of a way to think about the two. All right, moving along here. So a Docker image is the basis of a Docker container, and it represents a full application, whereas a container is the standard unit in which the application service resides and executes. So moving right along here. So let's make sure that this is able to play here. All right. So here you can see me pulling my Docker image. I'm just using a really simple application called whalesay from the Docker registry. So we'll go over what all these really exciting numbers and letter combos are in just a second. But those are our layers that are being pulled down. And Docker has checked to see if we have this locally. I hit it with my elbow again. Okay. Okay. And then it's pulling all of those down for us. All right. There we go. Not going to touch it anymore. So in your terminal, you can see all of your images by running the command docker images. So you can see that our Docker whalesay image is right at the bottom here. And of course, at this point, so I've pulled down my image. If I run a Docker container ls, what's going to happen? Nothing is a trick question, you guys. Nothing's going to happen because we have not spun up a container yet. So the image is our base image, and so here, spoiler alert, you know what's going to happen. We're going to run a Docker container ls, and nothing happened. Boom. So a question that I get a lot, especially when I'm teaching newer people about Docker, is, so Docker, a container is sort of a lightweight VM, right? No. I'd have to disagree. Oh man, my GIFs are just not, okay, it's worth it. No. So it's not like that at all, and I will go into the details why. So it may appear that there are some similarities between the two, but Mike Coleman, whose talk is actually following mine, has a very helpful article that breaks this down, and that's the comparison between houses and apartment buildings. So in this case, you can think of VMs like a house and containers like an apartment building. Okay, there's a lot of metaphors. Stick with me here. I promise it makes sense. So houses, so VMs in this case, are fully self-contained, and they offer protection from unwanted guests. And they also possess their own infrastructure. So that can be plumbing, heating, electrical, all those fun things. And houses are going to have at minimum, a bedroom, a living room, a kitchen. And you may end up buying more than you need simply because that's how houses are built. Does anyone know what this GIF is from? Maybe? No, very close. It's from Little Shop of Horrors, somewhere that's green. There we go. Don't worry, there's not a real test, you guys. All right, and then apartment buildings. So these are different in the sense that they also offer protection from unwanted guests, but they're built on a shared infrastructure. So the apartment building, in this case the Docker host, shares all the plumbing, the heating, the electrical, and additionally apartments are offered in all different kinds of sizes. So you can have a studio, a 1-bedroom, a 2-bedroom, a 3-bedroom, and you're only renting exactly what you need. And finally, like houses, apartments, they have front doors so they can keep out unwanted guests. Anyone know this one? This is, yes, good job. So let's review. Each Docker command creates a layer, and then we pull the layers. So each branch of layer in a Docker image shares those common layers. So this allows images to be constructed and deconstructed as needed. And this differs quite a bit from a huge monolithic application. So you can see how Docker is not a virtual machine in this case. So when a container is started, a writable layer is added to the very top of our file system. So we're really only getting exactly what we need. So with containers, oops, let's make sure that my GIF is popping up here. All right, so if you walk away from anything from this talk, and if you want to sound very cool at the after party tonight, when someone starts to make the comparison between a virtual machine and Docker, you can quote Mike Coleman, and you can say, Docker is not a virtualization technology, it's an application delivery technology. Tattoo that on your arm or something, and then look at it later when someone tries to make that argument with you. So layers. So instead of pip installing various technologies on a VM, often getting a lot more than you actually need, with Docker you can grab the specific parts that you require. So it's like putting together the different pieces to kind of create this perfect application with no extra weight on it. But what if I told you that Docker itself had its own pieces? Well, now we can talk briefly about layers. And of course, I would be remiss if I did not mention Shrek. Ogres have layers, they're like onions. That's actually me in the center in Shrek the Musical, so my life was very different 4 years ago. So let's move along. So the first time that you pull an image from DockerHub, it is going to look a little bit like this. Excuse me while I'm on my tiptoes here to see. So as you can see, once we pull this, we're going to have to wait for each pull to load here. But when I do this a second time, and I'll just skip, spoiler alert, this ends up loading at the end. But if I skip over here, you'll see that Docker is smart enough to know, if I pull this again, that I already have that locally. So we're going to run the exact same thing. So Docker pull Python. And it checks to see if I have it. Cool. It knows that it's there. So believe it or not, this is not witchcraft. This is the awesomeness that is layers in Docker. And the beauty of layers is that it means a lot less uploading and downloading for you. And you know how much I love visual examples, so I'm going to do another one. I'm really sorry if this makes you hungry. I know we're getting really close to lunch. So let's say we had a cheese pizza, and we have a base layer of dough, we have tomato sauce, we have cheese, and then I decide that I want a pizza with pepperoni on it. But if I just want to, kind of use what I have, do I bake another pizza from scratch, or do I just add pepperoni to that one? I'll just add pepperoni to the other half. So you can see here, you don't have to go through the trouble of making a whole new base pizza, or it's a layer in a sense. When we make more changes, we create more layers. So in this case, we have image 1 and we have image 2. So how does this work when a base image gets changed? Well, Docker uses copy on write. So this means that it would take the changed base image and then store a copy of it in that container layer. So keeping to our pizza metaphor, we would take out a slice of pizza from the pie, put some jalapenos on top, maybe dip it in some hot sauce. Maybe I'm the only person who does that. And then we put it in its own Tupperware for later. So the purpose of copy on write is to not create new resources unless we absolutely have to. So we can share those resources between the copy and the original, in this case, the cheese and the pepperoni. But when we fundamentally change the base layer, so dipping it in hot sauce per se, we have to save it in its own container. Thank you, Amazon.com, for letting me know I can just save one pizza in a container. So why do we want to store each layer only once? So we're saving space, And this does make the host less crowded, so we avoid duplicates, and it makes for less pushing and pulling between registries. So this allows images to be constructed and deconstructed as needed versus this huge monolithic application like a virtual machine. So when a container is started, a writable layer is added to the top of the file system. So remember, Docker has layers. It's like Shrek. So DockerHub. Of course, it's important to touch on DockerHub. And you can see here that I'm actually logged into my own account on DockerHub, where I'm storing some of my own images. Oops. I'm just skipping through the GIFs, you guys. Let's go here. Alrighty. So I'm, in this example, going to search for Python. And as you can see, this is labeled as an official image. So that means that it's updated and maintained by a dedicated team. So you can rest assured that any official images are going to have security updates, and they're going to be applied in a very timely manner. So official images are provided by Docker. And in this repo, you can see the details of how to pull this image, as well as the tags for that image as well. So it's really all in one place. It's pretty self-explanatory. I would recommend taking a look around on DockerHub to see what's on there. They have pretty much everything. And they have ASCII Star Wars as well, if you want to play with that. So if you're a Docker user, when you run Docker image ls, you've seen something similar to this, listing out the info of the images that you have. So we have three sort of ways here to identify what we have. We have repository, we have tag, and we have image ID. And since repositories can have duplicate names and image IDs, and we don't really, who's going to remember this Wi-Fi password of a thing like B512EBCAC9? I certainly can't. So sometimes we need an easier way to identify them. So that is where tags come in. Sadly, not the Macklemore kind of tags, but I personally find Docker just as exciting as thrift shopping. So in the world of Docker, tags point to a specific image commit for an image ID. So you've probably seen the tag latest quite a bit. And this is a default tag in Docker, and it's really important to note that it's less of a most recent kind of a description and more of a kind of a default for Docker. Little Docker pro tip for you. So for example, if I go to the official Python registry on DockerHub, the full description area lists all the supported tags, as you can see up on the top part there, as well as the words that go along with them. So you can see that images can have multiple tags associated with them. So for example, if I run, Docker pull python 2-wheezy, it's going to load that one. And similarly, if I decide I want a slightly newer version of Python, Docker is intelligent enough to know that that image is already in my cache. So even if I were to run the exact same version under a different name, Docker is going to be smart enough to know that. So I won't spend too long on this because you guys get the idea. But we're doing another version of Python in the same line, and it's going to know that it's there. So Docker's smart. Docker's smart, y'all. So you can see here, I see, oops, there we go. There we go. I can see two Python images with the same image ID here, but two different tags. And image caching is one of the things that makes Docker so lightweight and awesome. So let's create a tag for my whale say example. So I'm going to specify the image I'd like to tag, and I'm going to add my username so I can push it to the Docker registry. And after I do that, I'm going to run a Docker image ls, and you'll see that my tag's going to be there. So obviously, when I made this example, I forgot how to spell my own name. That happens a lot. But Chloe Codes Things is the name of my repository on DockerHub, and I'm putting will say, and I'm tagging it as DockerCon. Cool. And then I'm going to do a Docker image ls. Awesome. So you can see that it exists. It's there. So if I push that by running the following, pretty simple command here. I'm going to do a Docker image push, and then I'm going to put my repository, and it'll push that to DockerHub. Cool. Ta-da! There it is. It's on DockerHub. So by giving a new tag to an existing image, when I push it to Docker, it'll create a new repo for me. And if I go to tags, my DockerCon tag will be listed there as well. And you're more than welcome to play around with WhaleSay on DockerHub and do the exact same thing that I did if you want copies of my slides. Very easy to do and play with. So let's touch on Dockerfiles. We've got about 10 more minutes here. So Dockerfiles are instructions that you need to optimize. You can think of Dockerfiles as the instructions of how to build your Docker image, because that's what they are. So Docker builds images automatically by reading the instructions from a Docker file, and it's a basic text file that contains, in order, all of the things needed to build a given image. So there's a very specific format that you need to use, and I'll dive into some of the common Dockerfile instructions today. So there's a couple of things to consider when you are creating a Dockerfile. So first of all, containers should be ephemeral. And by ephemeral, I mean that they can be stopped and destroyed, and you can build a new one and put it in place of another with very, very minimal setup and configuration. Secondly, there should be no unnecessary packages. You should avoid installing anything extra. That's really the beauty of Docker being a lightweight system. You don't really need any of those nice-to-haves. In order to just reduce complexity, dependencies, file sizes, and also build times as well. Additionally, each container should have only one concern. So decoupling applications into multiple containers makes it way easier to scale horizontally. And for instance, if you have a web application, it might consist of 3 different containers. They all have their unique image. So to manage a web application, a database, you want to have them in a decoupled manner. And finally, you want minimal layers. So you want to minimize the amount of layers that you use. So you really want to find that balance between readability and long-term maintainability of the Docker file, and really minimizing the number of layers it uses. So you want to be strategic, and you want to be cautious about the amount that you have. So here is a Linux example of a Docker file. It's pretty readable, as you can see. So just diving into the different sections here. So we have the from instruction, which is going to create a new build stage, and a valid Docker file has to start with a from instruction. So an image can be any valid image, and it's especially easy to start pulling an image from a public repository. The run instruction will execute any commands in a new layer on top of the current image and commit the results. So the resulting committed image will be used for the next step in the Docker file. Next, we have copy. So the copy instruction is going to copy any new files or directories and add them to the file system of the container at the path. And then we have expose. So expose is an instruction that will indicate the port on which a container will run and listen for connections. And then finally, we have command. So the main purpose here is to provide defaults for executing the container. So there can only be one command in a Docker file. So if you list more than one, the last one will be the only one that takes effect. In addition, for you Windows users out here, here's an example of a Windows Docker file. The syntax here is going to be just a little different, obviously, for Windows, but it's the same idea with very similar commands. And there's a lot of documentation about this online if you want any help with that. So volumes. So volumes mount a directory on the host in the container at a specific location. So you're probably thinking, okay, Docker's very ephemeral. I spin it up, I break it down. What happens to my database? So this is where volumes come into play. So since containers can be quickly created and quickly destroyed, we really want to make sure that that information is safe. So Docker came up with the concept of volumes to help us save persistent data and to help us kind of save that data between containers. So volumes are files or directories that live outside of the Union file system, and this makes them separate from the container itself. So it makes it much more difficult to remove them on accident. So by having this sort of separation of concerns, it really removes any worry of that happening or your data being impacted. And of course, this is from Spinal Tap, one of my favorite movies. We have to turn the volume up to 11. Alrighty. So volumes are designed to persist data independent of the container's lifecycle. So Docker, therefore, automatically will never delete volumes when you remove a container, nor will it ever garbage collect volumes that are not being referenced by the container. So your information is safe. So if you've seen a Dockerfile before, you've probably seen the volume command. It usually looks a little something like this. And what it's saying is when you start a new container, make a new volume location and assign it to the directory in the container. So volumes need manual deletion. And the volume will still be there if you remove the container. So this extra step really provides that extra layer of protection. And there's 3 types of volumes. We have host volumes. There we go. Whoop. These live on the Docker host file system, and they can be accessed from within the container to create a host volume. An anonymous volume. These are very useful when you'd rather have Docker handle where the files are stored. It can be difficult to refer to the same volume over time with an anonymous volume. So to create an anonymous volume, you would just kind of run something similar to the following. And then a named volume is going to be similar to an anonymous volume, but Docker is going to manage where on the disk the volume is created. But you give it a volume name to create a named volume. Hence the name named volumes. I told you guys I have bad dad jokes. It's a disease. All right, so there are 3 types of volumes, as we covered. And you can really think of volumes as a baton in a race that's being passed between the different runners. So with each new lap, the runner is passing items and exchanging them between each other, so to make sure that it's consistent. So in this example, the runners would be our containers, and the baton, or the drumstick in this example, is our volume. So when we run a container, you can run Docker volume to see your running containers as a command. And this will spit out a interesting, long, similar Wi-Fi number value. But Docker has named volumes, as I mentioned before. So I won't go into the details of that for the sake of time, but there's a lot of useful stuff on the Docker documentation. There's our little container running with his volume. So let's see, we're coming up at the end here. So I'm just going to quickly touch on Docker Compose. So with Docker Compose, we define and run multi-container applications within Docker. So to quote the Docker docs, Compose is a tool for defining and running multi-container Docker applications. So with Compose, you're going to use a YAML file to configure your application services. And then with a single command, you create and start all of the services from your configuration. So that's the second thing that I did in my demo from earlier. That kind of seemed a lot more easier to spin that up. We were using a Docker Compose file. So 3-step process. You want to define your app's environment with a Docker file so you can reproduce it anywhere. And then define the services that make up your application in Docker Compose so they can be run in an isolated environment. And then lastly, run Docker Compose up, and Compose will start and run your entire app. So the main function is to kind of create a microservice architecture. And then all the containers and the links between them can be put together. And the tool is capable of a lot more that I will not go into at this time. So we're a little limited on time here, so I am not going to do my demo a second time, but I'm actually doing one of the hallway tracks right after this. So if you want to talk after, or if you want to go to the hallway area, I'm happy to break this down a little bit more for you and walk through that on a step-by-step level where you can ask questions along the way. So some really great resources going forward. So play with Docker. This is a really great way to play with Docker without actually downloading Docker. You can just play with it on the interwebs, and I would highly recommend playing with it. There's a lot of really great tutorials online from Docker. Brett Fisher's class on Udemy is awesome. I would highly recommend it to ramp up on your Docker skills, especially if you're just trying to get a little bit more beyond the basics of what we learned today. The Docker Docs, of course, and anything from a Docker Captain. If you're unfamiliar with the Docker Captains program, you can check it out online, docker.com/captains. A lot of really amazing people writing and blogging and tweeting and all the things about Docker, so definitely check that out. So, and also CodeFresh. If you're looking to build, test, deploy, maybe spin up a on-demand staging environment, CodeFresh is a really great application for that, and I'm happy to give a walkthrough of that afterwards as well. So thank you for coming. I'm at Chloe Condon on most things. My articles on Medium cover Docker basics, volumes, tags, pretty much everything that we covered today, so definitely take a look at that. And come to my hallway track after this, because otherwise I'm going to be chilling in that foam pit by myself. So come on down, and thank you so much for coming, everyone.
We have time for about 5 minutes for questions. So if you have any questions, please come up to the microphone. Or see her in the hallway track later.
Thank you. Where do you define your repo on when you push the image? You didn't put any directory or so on. So did you define before in any kind of file or?
Hello. So I can actually show you that in the hallway track. I had it in a repository on my terminal already. I just didn't go back enough to show that. Yeah. Ooh.
Any other questions?
Oh, my mic's back on.
So what would you say, because you did Docker Compose up to bring up your containers using your Docker Compose file, but Docker run, when you were not using the Compose file. So why the difference?
Yeah, so the first time I did it, in the demo that I did, I was just building it locally, but the compose file is going to connect any different containers that I have separately. So a lot of times you can spin up one container in the first scenario, but the second one's really going to, let's say you have like a chat application that's a Node.js application with a Mongo database, you want to be able to spin both of those up. So that would be an instance for Docker Compose.
Any other questions? Great. Thank you.
Thank you, everyone.
Enjoy your lunchtime.